Assalamualaikum and hi everyone. Right, so today we are going to continue our lesson on this topic, okay, acid and base. Right, so today we are going to cover a learning outcome I and J that is referred to the definition of buffer solution and then describe how a buffer solution controls its pH. Okay, so in our daily life, alright, so buffer solution, it has the ability, alright, to control the pH of blood. So this is blood in capillaries, so it can control the pH of blood in our bodies, remain constant with pH of 7.4. Okay, buffer are also used in our bodies in the hemoglobin complex, okay, which helps the body utilize oxygen better. Right, so now buffer solution. So what is buffer solution? So it is a solution that has the ability to resist changes in pH upon addition of small amount of either acid or base, which means that the pH does not change even after the addition of small amount of strong acid or strong base. So a buffer solution, it must contain acidic component which it can react with added hydroxide ion, and it should have basic component that can react with added H3O plus ion. Okay, therefore buffer solution is a solution that contain a weak acid and its salt or its conjugate base, or a weak base and its salt, that is its conjugate acid. Okay, so for example, like unbuffered solution, so we have a dilute HCl with the concentration of 0.01 molar. So initially the pH is 5. So after the addition of 1 molar HCl into the dilute HCl, what will happen? So the concentration of H plus ion will increase, and therefore this will change the value of pH. So the pH would become lower, that is pH equals to 2. What will happen when addition of 1 molar NaOH? Alright, so when we add more NaOH, so the concentration of OH minus ion inside HCl solution will increase, and therefore it will affect the pH values. So pH will increase and become 12. Right, so we can conclude that here for unbuffered solution, so when addition of strong acid and strong base, right, so the pH will change. Either it will increase when addition of strong base, or it will decrease when addition of strong acid. Alright, so for the buffered solution, for example, that the mixture of 1 molar ethanoic acid, that is referred to as weak acid, and 1 molar of sodium ethanoate, that is referred to its salt, right? So the initial pH is 5. Okay, what would happen when the addition of 1 molar HCl? Already known that the concentration of H plus ion will increase. However, the buffer solution able to maintain its pH and become 4.98. What will happen when the addition of 1 molar NaOH? So when we add more NaOH, so actually the concentration of OH minus inside the buffer solution will increase. Right, so however, buffer solution are able to control its pH and it remain 5.02. So we can see that after the addition of strong acid and strong base, so the pH does not much affected. A buffer solution is referred to a solution with the mixture of weak acid and its conjugate. For example, like ethanoic acid and sodium ethanoate. So this is weak acid, and this is its salt. Right? So it should have two components that is referred to the basic and acidic component. So as for this buffer solution, right, so the basic component is referred to the ethanoic ion. That is mainly come from the salt. Okay, and the acidic component is referred to the weak acid, that is ethanoic acid. Alright, so for a mixture weak base and its conjugate acid, such as ammonia and ammonium chloride, it should also have two components that is referred to the basic and acidic. So the basic component is referred to the weak base, that is ammonia, and the acidic component is referred to the conjugate acid, that is NH4+. That is mainly come from the salt. Right, so now example, which of the following are buffer system? Right, so we have mixture of KF and HF, KBr and HBr, sodium carbonate and sodium hydrogen carbonate. Right, so for A, KF and HF, right? Right, so HF here is a weak acid. And in this mixture also contain F- that is conjugate base. So it has two weak acid and conjugate base. Right, so therefore KF and HF is a buffer solution. Right, so for B, KBr and HBr. Okay, so HBr actually is a strong acid. Okay, so therefore the mixture of KBr and HBr is not a buffer solution. Okay, so next C. So we have sodium carbonate and sodium hydrogen carbonate. Alright, so for carbonate ion is a weak base, whereas for the hydrogen carbonate is a conjugate acid. So it has the combination of weak base and conjugate acid. Therefore, the mixture of sodium carbonate and sodium hydrogen carbonate is a buffer solution. So we can conclude that a buffer solution, it should has the mixture of weak acid and its conjugate base, or it should have weak base and its conjugate acid. There are two types of buffer solution, that is acidic buffer and basic buffer. An acidic buffer solution can be prepared by mixing a weak acid and its salt, that is conjugate base. For example, like acetic acid and sodium ethanoate, that is referred to its salt. So what are the reaction occur in the buffer solution? So there are two reaction occur. So the first reaction is dissociation of salt. Sodium ethanoate exists as a solid and it will 100% dissociate or completely dissociate into ethanoate ion and sodium ion. So because of that, the arrow that we use here is forward arrow. So meaning that at the end of the reaction, there is no more salt in the buffer solution, since it is completely converted into ethanoate ion and sodium ion. For the second reaction, that is referred to the dissociation of weak acid, that is referred to the acetic acid. So acetic acid exists in aqueous, so it will partially dissociated, since it is a weak acid, and it will form ethanoate ion and H+ ion. So this reaction is reversible reaction. So because of that, we have to use the reversible arrow. So based on these two reactions, we can clearly see that both reactions will produce the same anion. Okay, that is referred to the ethanoate ion. However, between these two reactions, so the ethanoate ion is mainly produced by the dissociation of salt, since salt can completely dissociated, whereas for the weak acid only partially dissociated. We can conclude that at equilibrium, acidic buffer contain weak acid and its salt. that is referred to the conjugate base. How does an acidic buffer control its pH when addition a small amount of strong acid? Okay, when a small amount of strong acid is added, the H plus ion will be neutralized by the ethanoic ion. Okay, that is referred to the conjugate base to form acetic acid. That is referred to the weak acid. Because of that, the concentration of H plus ion remain constant. So as the result, there will be only a small change in pH. And the concentration of the conjugate base, that is referred to the ethanoic ion, will be decreased since it is react with the added H plus ion. Whereas for the concentration of the acetic acid, it will increase. How does an acidic buffer control its pH when a small amount of strong base is added? Okay, when a small amount of strong base is added to the buffer system, the OH ion, OH minus ion will be neutralized by the acid that is referred to the ethanoic acid to form conjugate base, that is ethanoic ion and water. So hence, the OH minus added is consumed. So as a result, there will be only a small changes in pH. The concentration of the ethanoic ion that is referred to the conjugate base will increase. Whereas for the concentration of ethanoic acid, it will decrease since the added OH minus ion is neutralized by the weak acid and it will produce more ethanoic ion. Basic buffer can be prepared by mixing a weak base and its salt, that is its conjugate acid, for example like ammonia and ammonium chloride. So what are the reaction occur in buffer solution? So there are two reactions occur. The first reaction is dissociation of salt, that is referred to the ammonium chloride. So ammonium chloride exists in solid, it will 100% or completely dissociate into ammonium ion and chloride ion. So this reaction is irreversible reaction and you have to use forward arrow. This means that at the end of the reaction, there is no more salt in the buffer solution. Okay, because it is 100% dissociate into ammonium ion and chloride ion. For the second reaction is referred to the dissociation of weak base. So ammonia that is exists in aqueous, it will partially dissociate in water and it will form NH4 plus ion and OH minus ion. So this reaction is reversible reaction and you have to use the reversible arrow. Based on both fraction, we can see that it will produce the same cation that is referred to the ammonium ion. However, ammonium ion is mainly produced by the dissociation of salt, since salt can 100% dissociate. So we can conclude that at equilibrium, basic buffer contain weak base and its salt. Okay, that is referred to the conjugate acid. Okay, how does a basic buffer solution control its pH when small amount of strong acid is added? Okay, when a small amount of acid is added, the H plus ion will be neutralized by the ammonia that is referred to the weak base to form conjugate acid, that is NH4 plus. Okay, so concentration of H plus remain constant. As a result, there will be only a small change in pH. The concentration of ammonia will decrease since the added H plus ion is neutralized by the ammonia and the concentration of ammonium ion it will increase. So how does a basic buffer solution control its pH when a small amount of strong base is added? Okay, if a small amount of strong base is added to buffer system, right, so the OH minus ion will be neutralized by ammonium ion that is referred to the conjugate acid to form ammonia, weak base and water. Hence, the added OH minus ion are consumed. As a result, there will be only a small change in pH, the concentration of NH3 will increase. And the concentration of NH4 plus ammonium ion will decrease. So because of the added OH minus ion is react with ammonium ion and produce ammonia. Okay, that's all for today. Thank you and Assalamualaikum.